During this tutorial, we will create a complete Kotlin Android CRUD application following MVVM architecture. You will be able to learn about Room Data Persistence Library, DataBinding, ViewModel, LiveData, Kotlin Coroutines, and RecyclerVIew. You will also be able to learn about MVVM best practices for data validations, data verifications, and displaying messages. I have also added the download link of the final code project below. I hope this tutorial will be very useful to you. So, let's start. Let's start by creating a new Android Studio project. I am naming this as Room Demo. Now, let's open the app level Gradle file. For this project, we are going to use libraries such as DataBinding, ViewModel, LiveData, Room, and Coroutines. So, let's start by enabling data binding. We should enable data binding inside this Android block. Data binding enabled equals true. And sync. Then we will add required dependencies for ViewModel and LiveData. We can copy them from this page. Until last month, we had this lifecycle extensions dependency, which is used commonly for both ViewModel and LiveData. But it is deprecated now. So we had to add dependencies for ViewModel and LiveData separately. We also need to add Kotlin kept plugin. Kept plugin is Kotlin annotation processor. Especially with Room library, we need to do a lot of annotation processing. We can get kept plugin details from this Kotlin documentation. Let's add kept plugin to our app level Gradle file. Now, we can add this annotation processor dependency for the lifecycles. Next, for the Room library, let's add these dependencies. Here, we need to change this to kept. Since we are going to use coroutines to handle background threads for Room, we need to add the coroutines support for Room dependency. Then, I am going to add required dependencies for coroutines. We need to add both Co and Android dependencies. You could find them from this Coroutines GitHub page. Let's sync the project. We will also need RecyclerVIew and CURD dependencies, but we don't have to manually add them. Andriod Studio will automatically add them when we are using those components for the first time. For our small demo project, we need to create this table in our database. Table name is subscriber data table, and we will have 3 columns: subscriber ID, name, and email. Subscriber ID should be the primary key. So I am going to create a data class with these properties and annotate it with entity annotation. Room library creates a table for each class annotated with entity annotation. So let's create a new Kotlin class. I am creating a new package for database related classes first. Let's name this class as subscriber. I am going to make this a Kotlin data class. Now we will add 3 properties: ID of type int, name, and email of type string. First of all, we need to annotate this class with entity annotation. Here we can mention the database table name we want Room to give when Room creates a table corresponds to this data class. If we do not give any name like this, Room will just use the class name subscriber as the table name. We can also use column info annotation to specify the name of the corresponding column in the table if you want it to be different from the name of the member variable. Giving separate names for the database table than just using the names of the data class is the best practice, because in a larger project we might need to use this same data class for other tasks and with other libraries. Next, we need to specify a primary key for this database table. We can set the primary key by adding primary key annotation to this subscriber ID field. We want this primary key to auto-generate. So, let's set the auto-generate property as true. So, that's how we create an entity class for a Room database. Data Access Object Interface or DAO interface is where we define the functions that access the database. When we were using SQLite directly, we had to write larger database queries in a separate file. We had to write complex code logics to work with cursor objects. But now, Room does all the hard work for us, reading the information we provide using annotations. I am going to create a new interface. Let's name this as Subscriber DAO and annotate with the DAO annotation. Room will recognize this interface as a data access object interface after seeing this DAO annotation. Now, let's write a function to insert a subscriber object to the database. Suspend fun insert subscriber. Object type is subscriber. Now, most importantly, we need to annotate this with the insert annotation. Here, I wrote the name of the function as insert. This name is not important. You can provide any meaningful name you like. The most important thing is this insert annotation. Room library recognizes this function by reading the insert annotation, not the function name. Since we have added a subscriber object as the function parameter, Room will recognize that we need to insert a subscriber object to the database. And Room will generate required codes for that task in the background. Why do we have this suspend modifier? Room doesn't support database access on the main thread because it might lock the UI for a long period of time. Therefore, we need to execute these functions in a background thread. For that, we can use async tasks, RxJava or executors. But the most advanced, easiest and the most efficient way is Kotlin Coroutines. Since Room provides direct support for Kotlin Coroutines, Room facilitates us to write these functions as suspending functions with suspend modifier. A suspending function is simply a function that can be paused and resumed at a later time. I believe you all have learned fundamentals of Kotlin Coroutines and suspending functions during previous introduction to Coroutines section of this course. Now, if somehow you are determined not to use Coroutines, you can write these functions without suspend modifier. It will also work if you are using another way of background processing in the calling class. Also, we can write different versions of these insert functions. We can write a function like this to add multiple subscribe objects. To add a list of objects, function would be like this. We can also add a single object and a list. Sometimes, for a verification, we might need to get a return value. We can actually get the new row ID or row IDs as a return value of type long. The type should be either long or an array or a list of long values. If we are expecting to get the inserted row ID as the return value of these functions, they should be modified like this. On-conflict strategy is another important property we can set for these functions. If we make on-conflict strategy dot replace, this will try to insert the entity, and if there is an existing row that has the same ID value, it will delete the old entity and replace the row with the new entity. If we set it as ignore, it will ignore the complicit. But for this simple demo project, we don't need them. We only need the basic insert function. During other later sections of this course, when we are developing more complex projects, we will use different variations of this insert function. Now, let's declare a function to update a row of the subscriber data table. Suspend fun update subscriber. Function parameter should be an instance of a subscriber object. Annotating this with the update annotation is the most important thing. Function name is not important. We can also write this function adding a list of subscribers as the parameter to update an entire list at once. We can also write this function with an int return type. This will return the number of rows updated in the database. For now, let's keep these functions in their simplest form. Now, let's define a function to delete a subscriber. Suspend fun delete subscriber. Function parameter should be an instance of a subscriber object. Then annotate this with the delete annotation. Delete function can also have different variations. We can add more than one entities as parameters. We can also add a list of entities as a parameter. Same as the update, this delete function can also return an int. The value would be the number of rows deleted. Now, with query annotation, Room allows us to include a SQL query that would run when the function is called. Most importantly, this query will be verified at compile time by Room to ensure that it works well with the database. So there will be no database queries related runtime errors. This is a major advantage of using Room Data Persistence Library. I am going to create a function to delete all the rows from the table. Suspend fun delete all. Then annotate this with the query annotation. Then the SQL query delete from subscriber data table. This is the table name we have given in this subscriber entity class. Next, I am going to write a function to get all the data from the subscriber data table. Room facilitates us to get data from a database table as a live data of list of entities. These queries are called asynchronous queries. Because for these queries, which has a live data as a return value, Room always run them on a background thread by itself. So we don't have to write special codes to run them in a background thread. So we don't have to use coroutines, async task or executors to execute these functions. Let me show you how to write a function to get a list of all subscriber entities from the database as live data. Fun, let's say get all subscribers. Return type is a live data of list of subscribers. Then query select all from subscriber data table. So, what are the differences of this function and other functions we defined? We didn't add a suspend modifier for this function. Why is that? Because we don't need to execute this function in a background thread using coroutines. Since this function returns live data, room library do its work from a background thread. So, this is our data access object interface. I hope you understood everything I explained clearly. If you have any question, any not clear area, please ask questions from me. I am always happy to support you. So far in this section, we created an entity class for a database table and a DAO interface to manage its data. Now, to represent the actual database of the app, let's create an abstract class, which is a subclass of room database class. I am naming this as a subscriber database. This should be abstract and extends room database. We should annotate this with database annotation. Here, we need to provide the list of entity classes. We have only one entity class. Then, the version number of the database. This version number is important when we are migrating the database from one version to another. Let's talk more about database migrations in another lesson. Then, we need to declare an abstract reference for the DAO interface. In this small demo project, we have only one entity class and a corresponding DAO interface. If we had more entity classes, we would have listed them all here and defined the references for corresponding DAOs. Now, we can just create a new object and use this database class in other places of the project. But that is not the best practice. Usually, we should only use one instance of a room database for the entire app. To avoid unexpected errors and performance issues, we should not let multiple instances of database opening at the same time. Therefore, let's create a singleton here. In Kotlin, we create singletons as companion objects. Companion object, then the reference to the subscriber database. Let's annotate this with volatile annotation. Volatile annotation makes the field immediately made visible to other threads. Don't worry about this boilerplate code part. You don't have to remember this. You can copy-paste this code part to all your room database classes and change the class name and the database name. Fun, get instance, parameter is context, this returns a subscriber database. Then here we add a synchronized block. Lock is this subscriber database class, var instance equal instance, which we defined above. If instance is equal to null, instance equals room dot database builder. Here, we need to provide the application context as the context. Then, the name of this class. Then, the name of the database we want to create. Let's name the database as Subscriber Data Database. Build. Finally, return the instance. So, don't worry about this singleton creation code part. We use the same boilerplate code for all Room projects only by changing the class and database names. For this project, we are going to follow MVVM architecture. MVVM is the recommended best architecture for Android development by Google. MVVM stands for Model, View, and ViewModel. Model means all data management related components. Model has local database related components, remote data sources related components, and a repository. For this small project, we are not going to use remote data sources. We have already created an entity class, a DAO interface, and a database class which completes this part of the MVVM architecture. Now, during this lesson, we are going to create a repository class for this project. The purpose of a repository class is to provide a clean API for view models to easily get and send data. As Google documentation says, you can consider repositories to be mediators between different data sources such as local databases, web services, and caches. In our simple project, we only have a local database. Some of you might think, why should we create an intermediate repository class? Can't we directly communicate with the DAO from the view model? Yes, that is possible. But our goal here is to teach you about MVVM architecture. To learn MVVM architecture, to learn about best coding patterns, let's create a repository class for this project. I am naming this as Subscriber Repository. I am adding an instance of Subscriber DAO interface as a constructor parameter for this class because we are going to call to the functions of the DAO from the repository. First, I am defining a variable for LiveData of desktop subscribers. Well, subscribers equals, this should be DAO.getAllSubscribers. As we discussed during the previous lesson, there is no requirement to call to this getAllSubscribers function from a background thread, because Room library automatically processes these functions with LiveData as a return type in a background thread. All other DAO functions should be called from a background thread. We will use Coroutines in the ViewModel class to execute them, but to support that, we need to define these functions as suspending functions. Let's create a function to insert subscriber data. Suspend fun insert. Parameter should be an instance of subscriber. Then inside the function DAO.insertSubscriber. pass the subscriber instance as an argument. Now let's create a similar function for update. Then another function for delete. Finally, let's create a function for delete all subscriber data. This is the app we are going to create. In this main activity, we will have two text input fields to insert subscriber's name and email address. Then we will have two buttons, save and clear all. We will have a RecyclerVIew to display the list of subscribers. Text on the buttons should change for updates and deletes when the user clicks on a list item. So let's open the activity-main.xml file and start designing this layout. I am deleting this text view, and to make this simple, I am changing this layout to a linear layout. Width and height should be match parent. Set the orientation as vertical. I am going to set attributes easily from here. This is much easier than writing XML. Let's add a margin of 15 dp. Now an edit text for subscriber's name. Let's give the ID as name text. Width should be match parent. Height should be web content. Let's add a margin of 15 dp. But for the bottom, 15 dp might be too much. Let's change it to 5 dp. I am adding subscriber's name for the hint. Let's keep the text size as 18 sp and change the text style to bold. Let's also remove this text value. Okay, now we can see the hint. Let's just copy paste this for the email text input. Change the ID as email text. Then change the hint as subscriber's email. Also change the top margin as 5 dp. Now for these two buttons, let's add another linear layout and set the orientation as horizontal. By default, orientation has set as horizontal. The height should be web content. let's add a button. I am setting this ID as Save or Update button. Width and height should be wrap content. I am setting the text size as 18 sp and text style as bold. Then let's add another button. I am giving the ID as Clear All or Delete button. Width and height should be wrap content. And I am setting the text size as 18 sp and text style as bold. Then let's drag a RecyclerVIew to the bottom of this main linear layout. Android Studio needs to download the library. Let's click on OK. Now, if you check the Gradle, you will see that Android Studio has automatically added the Gradle dependency required for RecyclerVIew. Actually, we need this RecyclerVIew located in the main linear layout. So, I'm going to cut this and paste it below. Let's also remove this weight property. Set the height as wrap content. And I am giving an ID to this as subscriber RecyclerVIew. Let's set the margins. So our main layout is ready. Now let's create a ViewModel class for our views. Create a new Kotlin class. Name this as subscriberViewModel. This should extend the ViewModel class. To use functions defined in the repository class, we need to have a reference to subscriber repository. So let's add an instance of subscriber repository as a constructor parameter to this project. Now, for the subscriber's name and email, I am going to define two mutable LiveData variables. Type should be string. Let's annotate these with bindable annotation. Now let's switch back to activity main.xml file. To use DataBinding, let's add layout text as the outermost text of this layout. Then move namespace declarations. Next, I am going to add data tags. Here, just define a reference variable for the subscriber view model. Now, for the values of text properties of these two text input fields, I am going to bind input name and input email mutable live data values defined in the view model. As you have learned during previous sections of this course, we are using two-way data binding here. Now, for the text displaying on these buttons, I am going to define another two mutable live data in the ViewModel class. I am creating an init block here. Inside the init block, we should define initial display names to those two buttons. This should be save, and this one should be clear all. Why am I doing this? Because according to our plan, the text on these buttons should change dynamically. When the user clicks on a RecyclerVIew list item, the selected subscriber's name and email should display on input fields, and save button should change as update, and clear all button should change as delete. Now, let's bind these live data values for the text properties of buttons. Then, in the view model, I am going to create two functions. Fun, save or update, and fun, clear all or delete. Now, in the activity main.xml file, let's bind those functions to the on-click events of the buttons. Now, let's complete other functions of the ViewModel class. We don't need to create a special function to get the list of subscribers as live data. We can just call repositories subscribers variable. Let's create a function to insert a subscriber. Fun insert. Parameter should be a subscriber instance. From here, we can call to the insert function of the repository, passing the subscriber instance. As we discussed earlier, we should do this function call from a background thread. We could use ViewModel scope.launch for that. Since we are using Kotlin, we can even make this function more concise, like this. Now, let's create similar functions for update, delete, and clear all. For now, in this delete or clear all function, let's just add a code to call to clear all function. In this save or update function, let's write codes to insert a subscriber entity to the database. Well, name, data type is string, equals input name dot value. These values should not be null. Well, email, input email dot value. Insert subscriber 0 name email. Since we set the primary key subscriber ID as a auto incremental value, we can just add 0 as the ID for all subscriber entities. Room will just ignore it and add the auto incremental value. Let's write codes to clear the input fields. After saving is done, input name.value equals null. And input email.value equals null. Since our ViewModel has a constructor parameter, as we learned during a previous lesson of this course, we need to create a ViewModel factory class for this ViewModel. Let's create a new Kotlin class. Name it as subscriber ViewModel factory. Since our ViewModel class has an instance of subscriber repository as a constructor parameter, this factory class should also has an instance of subscriber repository as a constructor parameter. This should extend ViewModel provider.factory. Let's override the create function. This next code part is just boilerplate code we use for every ViewModel factory. I just copied it from our previous ViewModel factory example and changed the ViewModel name and constructor parameter name. Now let's move to MainActivity and write codes to use the ViewModel. First of all, I am going to write codes to get the DataBinding object. Then let's define a reference variable for a subscriber ViewModel instance. But before get a ViewModel instance using the factory class, we need to create a factory instance. To create a subscriber ViewModel factory instance, we need to pass a DAO instance as an argument. So let's start by creating a DAO instance. Well, DAO. During a previous lesson, we created a room database class which provides singleton database instance. We are going to use it here. Subscriber database.get instance. We need to pass the application here. Dot subscriber DAO. Next, I am going to create repository instance using this DAO instance. Then let's create a subscriber ViewModel factory instance using that repository instance. Now we can write codes to get a subscriber ViewModel instance. Then I am going to assign the ViewModel instance to the DataBinding object. Since we are intending to use LiveData with DataBinding, we need to provide a lifecycle owner. Now, I am going to create a function to observe the list of subscribers' data in the database table. Private fun, let's say display subscribers list. For now, we will just log the result, but later we will write codes to display these data on a RecyclerVIew. Let's write codes here to observe the list of subscribers which is in LiveData format. Here in the DAO interface, we have this getAllSubscribers function which returns a list of subscribers as LiveData. We call to that DAO function from the repository and assign LiveData to the subscribers property. Then here in the ViewModel, we get that LiveData from the repository. Now I am going to write codes to observe that LiveData from the MainActivity. Subscriber ViewModel .subscribers .observe. Lifecycle owner is this observer. Let's add a log here. There is one last thing to do. To use this bindable tags in ViewModel, this ViewModel class should implement the observable interface. This should be androiddex.databinding.observable, not the java.util.observable. We also need to implement its two functions. Let's just keep them empty. And from the main activities on create function, we need to call to this display subscribers list function. Alright, now it's good time to run the app and see this in action. To see the log results, let's use the tag name. I'm going to run the app now. Let's add a fake subscriber. We need to change this. These are the live data results. You can see the subscriber we just added have persisted in the database. Let's add another subscriber. You can see here, we got automatic live data updates, and look at the subscriber IDs. They are auto-incrementing as we intended. So, that means insert and query functionalities working well. Now, let's test the delete all functionality. You can see here, all subscriber data has been deleted from the database. Let's add a new one. Yes, new subscriber data persisted to the database as we intended. I'm going to add 2 more subscribers to the database. Now, during this lesson, we are going to display subscribers' data in a RecyclerVIew. To do that, as the first step, let's create a XML layout resource file for the RecyclerVIew list item. Select the resource type as layout. Let's name this as list item. Switch to text view. I'm changing this layout to linear layout. Set the orientation as vertical. I'm setting the bottom margin as 20 dp. Let's keep the layout width as match parent and change the height into wrap content. Now, to provide a much better design to the RecyclerVIew list item, I'm going to add a CURD view here. Android Studio is going to add CURD view dependency to the Gradle and download the CURD view library for us. Let's click OK. If you check your app level Gradle file, you will see this automatically added CURD view dependency. Now, we need to give an ID to the CURD view. Let's keep the layout width as match parent and change the height into wrap content. Then, let's set layout gravity as center. Then, let's set clickable property and focusable property as true. Next, let's set the primary color as CURD background color. Then, I am going to set the card radius as 10 dp. And the card elevation also as 10 dp. We need to add an ID to this layout. A text view to display the subscriber's name. Let's provide an ID to this as name text view. Set the width and height as wrap content. And let's add a margin of 10 dp. Then set the text color. Let's set the text style as bold and text size as 30 sp. Now I am going to duplicate same code for email text view. Change the ID as email text view and change the text size as 24 sp. Alright, now our RecyclerVIew list item is ready. Now, during this lesson, I am going to show you how to display this subscriber data on a RecyclerVIew. First of all, to use DataBinding, I am going to add layout text as the outermost text of this list item.xml file. Also, take the namespace declarations to the layout text. Now, let's create a class for the RecyclerVIew adapter. I am naming this as my RecyclerVIew adapter. As you have learned during the RecyclerVIew fundamentals section, this class should extend the RecyclerView's adapter class. When we are extending, we need to provide an adapter class as the object type. Therefore, we need to create another class which extends RecyclerView's adapter class. You could create this as an inner class or a separate class in the same file. I am going to create this as a separate class. Let's name this as my view holder. Since we are going to use DataBinding, we need to add the DataBinding object of the list item layout as the constructor parameter. Layout name is list item, so this should be list item binding. Then extend RecyclerVIew.viewHolder. Pass binding.root as an argument. We mainly use this class to bind values to each list item. For that, let's create a function. I am naming this as bind. Since we are going to have a subscriber instance to this, let's add it as a parameter. I am going to also write codes to bind values to the view of the list item. Our list item has two text views, name text view and email text view. Binding.name text view.text equals subscriber.name. Binding.email email text view.text equals subscriber.email. Alright, now let's go back to the main adapter class. Here I am going to define a list of subscribers as a constructor parameter. Let's name this as subscribers. Now, this adapter class should extend RecyclerView's adapter class. Type should be the class we created below. Then we need to implement these three functions: onCreateViewHolder, getItemCount, and onBindViewHolder. Now I am going to implement the onCreateViewHolder function. This is where we create the list item. To do that, we will use the list item XML layout template we created earlier. First of all, let's get an instance of layout inflator. Then we need to get the data binding object of the list item layout. Next, I am going to return an instance of my viewholder class, passing this data binding object as an argument. The data binding object will be used here. This getItemCount function returns the total number of items in the dataset held by the adapter. So this should be subscriberslist.size. Then we will implement this onBindViewHolder function. We use onBindViewHolder to display data on the list item. Considering the int value returned from this getItemCount function, RecyclerVIew library will create separate rows for each list item. This position represents that count value of each list item. So here we will get the relevant subscriber object from the subscribers list using this position value and pass it to the bind function of the myRecyclerView class. So our adapter class is ready for now. Let's go back to MainActivity and write codes to display the data in the RecyclerView using this adapter. Let's create a function here named initRecyclerView. I'm going to set a layout manager for the RecyclerView here. ID is subscriber_RecyclerView. We need to add the context. Now from here, let's go to the display subscribers list function. And from the MainActivity, let's go to this initRecyclerView function. Then we can set the adapter by passing the list of subscribers. Now it's time to run the app and see this in action. let's clear all data and add some data to test how this works. Good. Our app is working as we intended. During the previous lesson, we implemented the RecyclerVIew. Now, during this lesson, we are going to firstly add a click listener to the RecyclerVIew, and after that, we will implement update and delete functionalities. Here, in the main activity, I am going to create a function for the click event. This should take a subscriber instance as a parameter. This subscriber instance will be the corresponding subscriber instance of clicked list item. For now, let's add a toast message. Context is this. Let's display the name of the clicked subscriber. To implement click event, we are going to use Kotlin higher order functions and lambda expressions. Here, we are going to use a lambda expression to pass the function as an argument. Selected item, object type is subscriber, then the name of the function we just created. Pass the instance. Now, let's go back to adapter class and change its constructor for this new change. Private val click listener. Required object type is subscriber. Since this function does not return anything, we should add unit here. Alright, so now we have a click listener as a constructor parameter. Now let's add the same click listener to this bind function of this myViewHolder class as a parameter. Then from here, let's pass this click listener reference variable as an argument. Next, inside this bind function, I am going to implement the setOnClickListener function of the layout. Layout ID is listItemLayout, binding.listItemLayout.setOnClickListener. Inside this function, we will write codes to pass the selected subscriber instance. This will pass to the listItemClicked function defined in the main activity. Alright, now let's run the app and see how this works. Let's click on a list item. A toast message shown with the selected subscriber's name. So our app is working as we intended. Actually, we added this click listener to implement update and delete functionalities. When a user clicks on a list item, name and email of the selected subscriber should display on the text input fields, and save button should change into update button, and clear all button should change into a delete button. To do that, let's go back to subscriber view model and create a new function there named init update and delete. We should add a subscriber instance as a parameter. So we will pass the selected subscriber instance to this function. Now I am going to write codes to display the selected name and email on the text input fields. Input name and email are the LiveData values binded to those fields. Then I am going to define two variables which we will use later to implement update and delete functionalities. First one is a boolean value, private var is update or delete equals false. Next, private latenit var subscriber to update or delete. Object type is subscriber. Since this is a latenit variable, we have to define the object type. Then here, let's set is update or delete as true. And let's assign this subscriber instance to the subscriber to update or delete variable. Now, I am going to write codes to change the display text value of the buttons. Let's go back to MainActivity again. From here, let's call to newly created init update and delete function. Now, let's run the app and see how these new changes work. Good. Selected subscribers' details were displayed on text input fields, and buttons also changed as update and delete. Now, let's go back to MainActivity view model and implement clear all and delete functionalities. We have already created this function here. Now, I am going to add an if-else block. If is update or delete, let's call to delete function, passing the subscriber to update or delete instance. Else, let's call to clear all function. Now, inside this delete function, let's copy from here. Input name and email values should empty again. this should change to false. And these button values should change as save and clear all. Now we will implement save or update. Here I am going to add another if-else block. Let's call to update function. Here inside update function, we can add same codes we added for the delete. But for update, we need to set new updated values to the properties of the subscriber object. Let's do it here. Android Studio shows an error. Okay, well, cannot be reassigned. This is a good lesson for us. Not like Java, in Kotlin we have two modifiers to define a variable, val and var. If we are willing to update properties of an object, all those properties should be defined as var. So let's open our subscriber entity class and change all variable definitions from val to var. This should be var id. This should be var name. And this should be var email. Alright, let's go back to ViewModel class now. Now Android Studio does not show a red underline. Let's also update the email value. Now this is the good time to run the app and see this in action. Let's select a subscriber. I'm deleting this one. Yes, it worked as we intended. Then I'm going to update this one. Good, our app is working as expected. So that's how we implement update and delete functions. In different situations, we might need to communicate with the view from the view model to inform the user about the result. We might need to show a toast message or a snack bar. As an example, if we consider this project, we might need to show a toast message to inform user after successfully inserting a new subscriber data to the database. One way of doing that is creating a separate interface with some functions. Then make the activity implement that interface and invoking those functions from the view model. But that is not a correct approach because that violates the fundamentals of MVVM architecture. In MVVM, the view model should not know about the views. The view model should not have any reference to a view. We can use LiveData for events by creating a single live event class. The problem with single live event is that it's restricted to one observer. This LiveData will only send an update once. Use an event wrapper is the recommended best practice. An event wrapper class allows us to explicitly consider the state of the event. So now I am going to create a new Kotlin class. Let's name it as event. This is a boilerplate code you can reuse for all your Android projects. I'm copying this code part from this official Android developers publication on medium.com. This class will be used as a wrapper for data that is exposed via a live data that represents an event. You don't have to remember this code. You can just copy this class for all your Android projects. Now, let's switch back to subscriberViewModel.kt class. Here, I am going to define a mutable LiveData for the status message. Private val status message equals mutable LiveData we are going to use this variable for a string message. So the type should be string, but we are going to use newly created event class as a wrapper. Therefore, type should be an event of string. Then I am going to create a getter for this LiveData. Well, message LiveData. Type should be same as above. Then get. This status message is a mutable LiveData. Therefore, we can edit its value. We can assign different values to it, but it is a private variable. Therefore, we cannot access to it from the outside classes. That is the correct coding practice. We should do that for data security and for data stability. Then here we have created a public getter. Outside classes can just observe the LiveData. Since we are not willing to modify this, we don't need to define this as a mutable LiveData. Now let's go to insert function. Here I am going to update the value of mutable LiveData with the success message. Status message dot value equals event. We need to pass the string message here. Let's say subscriber inserted successfully. Then let's go to update function. Subscriber updated successfully. Then the delete function. Subscriber deleted successfully. Finally, clear all function. All subscribers deleted successfully. Now let's open the main activity. Here I am going to write codes to observe that LiveData. SubscriberViewModel.message.observe. Lifecycle owner is this. Observer. It.getContent if not handled. This avoids repetitions. Let's write the toast message here. Let's also comment this toast message. Now, I am going to run the app and see how these new changes work. Let's add a new subscriber. Okay, let's update this one. Good, our app is working as we intended. So this is how we display messages on the view without violating the MVVM architecture. Now, during this lesson, we will use return values of room for proper, much accurate verifications. Let's go to subscriber DAO interface. I'm going to start with insert function. A function annotated with insert annotation can return a long value, which is the new row ID for the inserted item. If the parameter is an array or a collection, it should return an array of long values or a list of long values. So let's get the newly inserted row ID. To get the newly inserted row ID, let's add a long return type. Now switch to repository class. We need to add a long return type to this corresponding insert function. Then add return here. So this function will return the newly inserted row ID. Next, let's switch to ViewModel class. Here, in the insert function of the subscriber ViewModel class, we can get the return value as new row ID. Then, for the verification, we will add an if-else using the new row ID. If any error happens, row will return the row ID as -1. So, if new row ID is greater than -1, else error occurred. Let's add the new row ID to the message. This is not necessary, but for the learning purpose, let's just add it. Now, I'm going to run the app and see how this works. You can see we have received the new row ID. Let's go back to DAO interface again. We can have this update annotated function return an int value indicating the number of rows updated in the database. Then I am changing the repository function accordingly. Next, change the ViewModel update function. Let's run the app and see how this works. Good, app is working as we intended. Now, also for the delete functions, we can have them return an int value indicating the number of rows removed from the database. Then let's modify repository delete functions accordingly. Next, switch to the view model. Let's say number of rows deleted. I'm going to do the same for this clear all function. Okay, now let's run the app again and see these changes in action. Let's delete this one. Functions are working as we intended. Now I am going to delete all subscribers. Good, our app is working as we expected. So that's how we can use return values from Room database functions for verifications. Now let's very quickly add some validations for the text input fields. Here I have opened the subscriber ViewModel class. I am going to write user input validations inside this save or update function. First of all, let's validate for null values. In our case, both name and email values cannot be null. If input name.value is equals to null, we can copy the message statement from below. Let's say, please enter subscriber's name. Email input fields also cannot be null. So, else if input email.value is equals to null, let's say, please enter subscriber's email. Next, we will write a validation for the email address. Entered email address should be in the correct format. Let me show you how to do it. Patterns, dot email address dot matcher, input email dot value, dot matches, This statement will give true if the entered email address in the correct format. But we want to send a message if it is in the incorrect format. So let's add this. Then copy the message. Let's say, please enter a correct email address. Okay. After these validations, we can allow user to save or update data. So, else, let's cut and paste them inside. So, this is our improved save or update function with validations. Now, it is good time to run the app and see how these newly added validations work. Let's test for the empty name and then for the empty email. Then I am entering an email address in incorrect format. Good. Our new user input validations are working as we intended. If you have studied our code well, you would have recognized that there is an inefficiency in this display subscribers list function. Every time we create a new subscriber, update a subscriber, or delete a subscriber, we create a new MyRecyclerView adapter object. We should have written codes to create a one adapter object and update it for database changes. Let's do it now. I am starting from the MyRecyclerView adapter class. Let's take this subscribers list definition from the constructor and keep it as a reference variable here. I am assigning an array list to it. Now let's define a new function to set the list of subscribers to this. Then let's write codes to clear the older list and assign the new updated list to it. Alright, now let's go back to MainActivity. Here we need to take this code part to init RecyclerView function. Since we need to refer to this adapter instance, let's define it as a class level variable. And here, let's construct the adapter. We don't need this parameter now. Then in this display subscribers list function, I am going to write codes to invoke setList function we just created, passing the updated list of subscribers as an argument. Earlier, we created a new adapter object for every new update. But now, we are just reusing the initially created adapter object. So, we must tell RecyclerView that there is a new update. This is how we do it. Adapter.notify dataset changed. Now, if we run this app, we will see app is working well as it worked before. But if you carefully calculate the loading time and memory usage of the app, you will observe that our new version of the app is much efficient than the previous. Right, that's all for this lesson. Thank you so much for listening. See you soon with the next lesson.